Okay, so let's look at the probability of drawing at least one black card when drawing 3 cards out of a deck. But the way we're going to do this is with replacement. So we draw a card, write down the color, put it back, shuffle them up, draw a new card, write down the color, put it back. So with replacement means we're going back to the full deck each time. The probability of at least one black card, well, anytime we have these at least scenarios, sometimes it's better to consider, right, is there an easier way if we think of the opposite of this, right? At least one black means 1, 2, or all 3 of these cards could be black. The opposite is that there are no black cards. So when we're using the opposite, we can do our complementary events. We say 1 minus the probability of whatever the opposite of this is. So no black cards. Since we only have black and red cards, you could say 1 minus the probability of all red cards. That's another way to say that. So let's think about the probability of getting no black cards. Well, if we do this one time, right, again, we only have black and red cards and they're equally likely. So if we do this only one time, there's a 26 in 52 chance from a standard deck of getting something that is not black, so a red card. But we know we're going to do this 3 times, and because this is an and scenario, right, the first card cannot be black, and the second card cannot be black, and the third card cannot be black. So we're going to do 1 minus this. Another way to write that is 1 minus 26 over 52 cubed, right? We're multiplying it by itself 3 times. So we can punch this into our calculator. I'm not terribly worried about what that number is. I'm more interested in the process. But this is a way to handle the at least type of scenario, is looking at our complementary event, 1 minus the complement.